Welcome to General Chemistry Mini Lecture Series, Lecture 32, The Wave Nature of Electromagnetic Radiation. As you may know, light is a form of electromagnetic radiation, and that is composed of two perpendicular waves. If the light is traveling toward this direction, so the blue one, the magnetic field, the blue one travels in this horizontal plane or perpendicular to this projection screen, while the electric field, the red one, travels in this projection plane toward this direction. The speed of the electromagnetic radiation waves is a constant. So when traveling in vacuum, the speed should be always 300 millimeters per second. Now let's address amplitude. Amplitude is the height of the wave. Basically, that's the distance from node to peak, or from node to through. The larger the amplitude, the brighter the light. So therefore, amplitude is the measure of the intensity. For those two waves, the first one has a smaller amplitude, so therefore, the light is dimmer. The second one, you see the amplitude is much larger than the first one, so therefore, the second light is much brighter. Wavelength is actually the distance between successive peaks or successive throughs. That's the wavelength, lambda. Frequency is the number of waves pass a point in a given period of time. For example, what shows here, so this is a period of 1 second. For the first radiation, there are 12 waves pass through a given point during this 1 second time period. So therefore, the frequency is 12 1/2. We also call that hertz. The second one, only 4 waves per second. Now, let's take a look at the relationship between wavelength and frequency. Obviously, the two are inversely proportional. The higher the frequency, the shorter the wavelength. The lower the frequency, the longer the wavelength. This is the key equation for the wave nature of electromagnetic radiation. C, the speed of light, equals lambda times nu, wavelength times frequency. You just need to know this key equation, but you have to be able to write other related equations in solving either frequency or wavelength. So therefore, from this key equation, if you need to solve frequency, you just move lambda to the other side as a denominator. So nu equals c over lambda. And you can do the same to find out lambda. That should be c over nu. And the speed of light in vacuum, 300 millimeters per second. Now let's work on the first example in this lecture. We have a red light that has a wavelength of 650 nanometers, and we need to find out its frequency. So what do we know? We know the wavelength. The speed of light should always be considered as a piece of known information, and we need to find out frequency. From this key equation, we should be able to write the desired equation for solving the frequency. So now we just need to plug in those numbers. C is 3 times 10 to the 8th meters per second, and then wavelength 650 nanometers. Please note, on top we have meters here, and on bottom we have to convert nanometers to meters so that we can have meters cancelled. All right? So that's why we have this conversion factor, 1 nanometer equals 10 to negative 9 meters. So as we can see, meters are cancelled, nanometers are cancelled. Your calculator will show you this number, but we need to take care of the significant figures, and that can be approximated to 4.62 times 10 to the 14th hertz. Let's work on the second example. In this question, we know the frequency, and we need to calculate the wavelength in meters. What do we know? We know frequency, speed of light. We need to find out wavelength in meters. Start from this key equation. Then we can write the equation needed. Lambda equals C over nu. What is C? C is 3 times 10 to the 8th meters per second. And then over nu. Nu is 89.7 megahertz. But if you look at the units on top, there's 1 over S, which is hertz. And on bottom, we have megahertz. So therefore, we need to convert from megahertz to hertz, which is 1 over S. So that hertz and hertz, or 1 over S and 1 over S, can be cancelled. And we know 1 megahertz equals 1 million hertz. So this way you can see 1 over S and 1 over S can be cancelled. Megahertz can be cancelled. Your calculator will show you 3.344 meters. However, we need to take care of the significant figures. In the original question, the number of sig figs is 3. So therefore, 3.34 meters should be the correct answer for this question. And we can also check the unit is correct because we need to find out the wavelength in meters. And this wavelength is appropriate for radio waves. Here are the end of lecture 32 quiz questions. I will see you guys in lecture 33.